Hello everyone. Today I am going to give a topic on type of function and operation on function. This is a subject of discrete structure and theory of logic. So in my topic, I will cover types of function, composition of function, and inverse of a function. So first, the topic is types of function. So there are 6 types of function: injective, surjective, bijective, into, one-to-one into, or many-one function. Here, injective is also called one-to-one function, surjective is also called on-to function, bijective is also called one-to-one function, into function, one-to-one into, and many-one. So first, injective function. What the injective function is going to state, the statement of injective function is that a function in which one element of domain set is connected to one element of codomain set. First we have to know about what is domain and what is codomain. That domain is the first element in a set A and codomain is the elements present in set B. Like as I am taking this F1, okay, this is set A, okay, if I will take A and B. So the set A contain A, B, C, D and B contain 1, 2, 3, 4, 5, 6. So set A is called as a domain and B is called as a codomain. Okay. Now after that, injective function, one-to-one function is going is state that all the codomain and the domain are related to each other by one element. They are not connected with many elements. Like I am going to describe that A is connected to 4, B is 5, C is 2 and D is 6. So it is one-to-one function. One-to-one function. Okay. How? Because these 4 elements are connected with the codomain with 4 elements. They are not connected with the multiple domain. Like if I will tell that A is connected to 4 and A is also connected to 5, then it is not one-to-one function. Like function 2, as here ABC is connected to 1, 2, 3. So it is also one-to-one function. Okay. Now from these 2 examples you can understand that what is injective function. Now the next is surjective. Surjective function is also called onto function, a function in which every element of codomain set has pre-image. Now we have to know about, as I have earlier discussed about the domain and codomain. Now I will discuss about the image and pre-image. What is the image and pre-image of the function? So here's A having the pre-image. This is A have the image here. The set B is called as the image of A. Okay, set B is called as a image of A. But what is the pre-image? The image having the reciprocal, that is known as pre-image. Like set A is called pre-image of A. Okay. Now the definition is telling that a function in which every element of codomain set has one pre-image. It means they have only the one pre-image. Okay. Codomain set have the one pre-image. Okay. So we are considering set A 1, 2, 3, 4 and B A, B, C, and function is related 1 to B, 2 to A, 3 to C and 4 to C. So the function, the range of the function is A, B and C, and these 3 are connected to set A. So these 3 are the range of this function. So codomain is A, B, C. Okay. Now bijective function. Bijective is also called one-to-one onto function, means it contain one-to-one and onto also. Okay, then it is known as the bijective function. Like the statement is going to tell about that a function which is both injective or surjective is known as bijective, that is 1 1 onto function. Okay, and in the previous slide you can take that you can say that the range is equals to codomain. It means the codomain contain the codomain like codomain. Okay, codomain contain ABC. Now the range having that the set contain that they are connected to the set D, and those elements are connected with set A, they are come in the range. So the range is A, B and C. So codomain equal to range. So this is surjective function. Now bijective, this is as I have told earlier that it has both injective and surjective. So this codomain, the codomain is equals to the range of domain. Yes, it is codomain is equals to range of domain, and it is 1 to 1. Okay, X is related to A, Y is related to B, and Z is related to X. So codomain contain, codomain I am writing CD, codomain contain A, B and C, and range contain A, B and X. Sorry, here it is X. Okay, so codomain is equals to range of the function. So that is, it means it is onto function, and now 1 to 1 function is saying that it is connected to the one domain, so that this function is bijective function. Now next, into function. Into function means a function in which there must be an element of codomain that does not have the pre-imaging domain X. Here in the simple statement I can tell you that the range of the codomain, the range of the function is not equal to codomain of the function. This is a simple statement to understand what is into function. So here I have written there the range is not equal to codomain of the function. So like this sorry, the codomain of this function is, codomain is 1 2 3 4. Okay, codomain is 1 2 3 and 4. Now range is 1 2 and 3. So CD is not equals to range, because R is not related to any, 4 is not related to anyone. So codomain is not related to codomain is not equals to range. So this is into function. So this is the simple definition, is that the definition of the into function is a function in which there must be an element of codomain that does not have pre-image in the domain X. Okay, and in a simple word we can say that the range of the function is not equal to the codomain of a function. This is simple statement of the into function. Now 1 1 into function. What 1 1 into function is going to tell? That the function should be 1 1 and it should be into. It means it should be 1 1 means one element is related to another element, and that the codomain of a function is not equal to the range of the function. Okay, now I am giving an example. X contain K, L, M and Y contain 1 2 3 4. Okay, the function is related there. A function is such that K to 1, L to 3 and M to 4. So the codomain is 1 2 3 4 and the range is 1 3 4. So it is into function and it is 1 1, because K is connected to 1, L is related to 3 and M is related to 4. Okay, this is simple example of 1 to 1. Many one function. Many one function is going to tell about that the function f is said to be many one function if there exists 2 or more than 2 different elements in X have same image in Y. Like one has X, the same image, X has same image 1, 2 and 3. This is multi times. So this is going to be tell as the many. Okay, and this is connected to 1 to 1. This is many one function. So you can understand that many means the one element have 2 or more different element in X. Okay, now next topic is composition of a function. So this is a new topic and this is the important topic for the discrete composition of a function. How we are going to discuss about that. Consider function f is such that a to b A to B and G B to C, the composition of f with G is a function from A to C defined by G O f of x. The definition is going to be tell about that. I am going to tell a simple statement about it. A function f, okay, is related to A to B, and function G related to B to C. Okay, now I am going to A is related to B and B is related to C. So we can show that A is related to C. Okay, so we have to write GOF of X like this. Okay, I am going to draw the diagram. How to draw the diagram of GOF, how it is related like this. 1 is related to A, 2 is related to A, and 3 is related to B. Now A is related to 5 and B is related to 7. So we can say that 1 is related to 5, 2 is related to 5, and 3 is related to 7. In the next slide, I am going to show you that. Like if I have the function this has given, and this is the function has given. So GOF of 1, how I have to find it? Like this. GOF of function 1 means I have to find 1. It means G of fx. The function fx defined as fx means 1 has a function a. So G of a. So what is G of a? G of a contain 5. So this is the 5. So I have found out the function G of f of 1. 2 also G of f of 2. F of 2 contain a. So G of a. So what is the value of G of a? 5. Done. Okay. G of f of 3. G of f3. G of f3. F3 has contained. F3 has b. So b. So G of b is 7. Okay. Like this we have to find the composition of function. Now I am going to take an example how to find GOF and FOG and all the functions of composition. So consider A equals to B equals to C equals to R. We have to understand the condition of the composition, what the question and what the question is going to be asked. So we have to understand it. Now the question is saying that A equals to B equals to C equals to R means these all are equal. So we have to understand from here that A equals to B equals to C equals to R. Now let function f is A to B, okay, and function g B to C, defined by function fx equals to fx x plus 9 and gy equals to y square plus 3. Now I am writing how to solve and find the composition of FOG of B and G of f of B. Here here B value is not given, but from this statement I can understand that these all are equal. So we have to find that how to find the composition of a function. Now first I have to write f of x, we have given x plus 9. Now g of y, what it has given, y square plus 3. Now the first question we have the ask. First I am solving here. FOG of B means f of g of B. Okay, so f of g of B, y is equals to B. I can understand that f of B equals to B plus 9 and g of B is equals to B square plus 3, because these two statements come from here. Okay, now g of B, what is the value of g of B? F of B square plus 3. Now what is f of B? B plus 9. So we have to put the value B here, f of B plus 9 whole square plus 3. Now you can solve it. Square formula, you have f B square plus 81 plus 18B plus 3 you can take. Okay, here we have to solve it. So the function, this is function, so B square plus 84 plus 18B. This is the solution of FOG of B. Now I am going to solve the second one, GOF of B. So GOF of B. we can put the value, okay, g of f of b. So g of f of b, so we have to put it. So value g of f of b. So f of b's value is g of f of b value is b plus 9, b plus 9. And what is g of b? We have to put b square. So we have to put g of b square. So we have the b square, okay, plus 9 plus 3. So b square plus 12. This is the answer of g of f of b. Okay. Now, next there is a theorem here for the composition. Let function f a to b and function g b to c be functions. That is a given. Function f is from a to b and g is from b to c. Be the function. If f and g are injective, means f and g are 1 to 1, then show that g of f, that is a to c, is an injective. Okay, we have to prove that a to c is an injective. Okay, so through the writing method, I have proved it. In the next slide I will solve by the diagram also. You can easily understand that how we have to find that a to c is an injective. Okay, so we have given that a to function f is a to b and function g equals to g is function b to c. So we are assuming a1 and a2 belongs to a. a1 and a2 belongs to a by the definition of the composition, and we have g of f of a1 equal to g of f of a2. It means g of f of a1 equals to g of f of a2, means the value, the g of f of a1 is equal to g of f of a2 is equal. So how it is equal? I am going to solve by the diagram. So function f is a1, function f of a1 equals to function of a2. Since g is injective, here it is given g is injective, from that g are injective, and for that f is also injective, so a1 is equals to a2, therefore g of f is injective. Now this is the writing method. Now I am going to solve you through the diagram method. How? Now we are going to say function is saying that function a and b, here it is a function. Okay, let us assume this is the a and b set function is related to each other. Now we are taking b and c. This is g. Okay, it is clear. Now we have given that f and g are injective. Okay, now I am taking the values. Okay, I am taking a, b, 1, 2, 1, 2, d, e. Okay, I have took the values in the sets. A is related to 1, b is related to 2, 1 is related to d, and 2 is related to e. This is given. Now you have to prove, or we have to prove, that g of f is injective, means a to c is injective. Now I am taking g of f of a. What should be the value? We have proved that, means g of f of a. So what is the value of f of a? F of a is 1. So g of 1. What is the value of g of 1? G of 1 is equals to d. Means if I am taking the value a and it is going to d. This is the one example how to show that g of f is injective. And now I am taking of g of f of b. So g of f of b. What is the value of f of b? F of b is 2. What is the value of g of 2? E. Now you can understand that these two are injective. From this method we can prove, from the diagram also we can prove that function f a to b and function g b to c are the two functions, and f and g are injective, so g of f is also injective. Now, inverse of a function. How to say that the inverse of a function? There is a statement how to find. Let function f a to b, a map g b to a is called the inverse of a function if GOF is equals to IA, means identity, and FOG is equals to IB, identity. So let us assume that G of fx equals to x for all x belongs to A, and G of f of gy is equals to y for all y belongs to B. Thus f of x is equals to y, then G of y equals to G of fx is equals to x. So the inverse of the G of function is denoted by f inverse, thus fx equals to y, so x equals to f inverse y. This is the writing method how to show that. Now I am going to say you in the brief and easy example. This is set A, this is set B, A is related to B and B is also related to A by f inverse. This is f inverse. Okay. Now in this statement, what is going to tell? I took a element x. Okay, x here and 1 here. Okay, here telling that g of fx, matlab GOF of fx is equals to x, then x belongs to A and g of y is belongs to y. In the easy method, I am telling that this is related to 1 is also related to x by f inverse. We can say that this is the inverse of a function. Now for inverse of a function, we have the example how to solve it. Now we are going to see it. Let set A equals to 1, 2, 3, 4 and set B equals to A, B, C, D, and function has given there. So that function f is a function, but f inverse is not a function. This is an important example of the inverse of a function. As we have learned in the definition that if the function is x is related to 1 and then 1 is also related to the x by f inverse. Now here it is saying that f inverse is not a function. How? Now we are going to prove it. We are saying the statement set A 1, 2, 3 and 4 and set B contain A, B, C and D. And what is the relation is given? Function is given 1 to A, okay, 2 to A, okay, 3 to D, okay, and 4 to C. This is also okay. Now, by the definition of a function, what we are saying that all the domain have to relate with the second set with any element, but there will no left over the in domain function. So this is domain and this is codomain. So by the definition of the function, we are saying that domain is all domain are related to each other. I know you can ask that, sir, how this one? This is the multi-one function. As I have told you, as I have read you there, many one function, what happened in the many one function. So this is also a many one function, but it is a function. Okay. So 1, 2, 3, 4 all are related. So this is the function. I am showing you the diagram. But now we are taking f inverse. Okay, for f inverse we are taking A, B and A. Now we are taking this one. This is the statement. F inverse means we can change it. Okay, now the B element I am writing A, B, C and D. Here we can write that f is a function. Here f is a function. Okay, but now we are taking f inverse. F inverse means we are taking A, B and A 1, 2, 3 and 4. Now we are going to relate it. Okay, how? There A is related to 1, good, is related to the 1, 2 is related to A, okay, 2 is also related to the A, okay, 3 is related to D, okay, and 4 is related to C. This is the given. Now we are saying that for inverse function, this is domain and this is codomain. Now, as the definition of the function is saying that all the element of the domain is related to the codomain of a function. Now, here I am, here is the function, the definition, but the domain B is not related to anyone. So, this is not a function. Now, I have interchanged it. So, this B to A means this is F inverse. Now, from the definition of function, F inverse is not a function. Okay, you have understand it. This is from this example how this function f is a function and f inverse not is a function. So this is the diagrammatical method to solve it. Now in the previous slide I am going to take you that how the inverse of a function is written. So now you can understand it. Function a, function f a to b, okay, function f a to b, and g b to a. This is g, okay, b to a is called the inverse of a f. G o f of g o of f is equal to a, means the element is in the this way or this way. The element are contained in the same place. Okay. If x is related to 1, then 1 is also related to x. This is I have written in the inverse of a function. Okay. Now I am going that you can understand that what is the types of a function and the composition of a function and operation of a function. Thank you so much.